extending Neyman Pearson for a composite HA. Okay. So almost all the tests until the last lecture had composite alternative hypotheses. Okay. So for a working example, suppose we want the test H0 theta equals theta 0 and HA theta greater than theta 0 at level alpha. So ahead of time, I am saying I want to set the probability of type 1 error to alpha, and I want to do this test. Remember, Neyman Pearson, when I had two simple hypotheses, gave me a test that set that level to alpha and also minimized the probability of type 2 error at that alternative hypothesis. Well, now I have an infinite number of possible values that lie in the alternative hypothesis. What we can do sometimes is use the lemma and find a test that will give me the most powerful test at every single value in the alternative hypothesis. So this is the strategy. So let's write strategy. Let theta A be in theta, okay, in the alternate, in HA. So in this case, theta A is greater than theta 0 in this example. Okay. Then, if the test given by the lemma if this test doesn't depend explicitly on theta A except for theta A in the alternate set. So if this doesn't depend on it explicitly, in other words, somehow this becomes, this is gone from this expression, then it must be, I must be able to use this for every theta A in there, because that's the only assumption I made, was that theta A is bigger than theta 0. So then the test gives the maximum power for every theta A in and is called a UMP test. This stands for universally most powerful. Okay, one remark is that K is set by alpha, so that's important, that's part of the statement. You want this test, you need it to be set at alpha, then you want to look at how the test does on minimizing type 2 error. Okay, so this is the trick. Now, if it does depend explicitly on theta A, you can't use this. So it works sometimes and generally requires just trying to compute it to see if it works. Okay. So we'll just follow this up with an example that works and just see how it might work. And I think that's going to do it, but this could take a little bit of time. So let's just see how far we get. We might have to break it up. Okay. Example. This is same example I did in the likelihood ratio test, so I hope that's okay. So suppose we have a sample that's normal and the variance is specified, but I want to test. Consider the test. I want to test the mean. H0 mu equal mu 0 versus HA. Say mu is greater than mu 0. And at level alpha. Okay, let's see if we can find a UMP test, if possible. Okay, so solution. We just let mu a be greater than mu 0, and apply the lemma. So then L mu 0 y, L mu a y is equal to 2 pi minus n over 2 exp and over here, same thing, almost the same thing, exp which is equal to, these cancel, and I have exp all this can come in here. Okay. And this less than k is by the maximizes power mu a, well, when k is set by alpha. Okay. So we want to see, though, I mean, so far we can't tell. We have mu a over here, and I have k over here. We have to do a little more computation to see if the test depends on mu a. So far it looks like it does, but it turns out it doesn't. Okay, how much time do we got? Okay, so here's where we are, and let's actually stop, and we'll continue this in the next lecture. So part 1 and part 2 of this one.